Hello and welcome back to the 3.11 notes about related rates. And we've got a problem here, and this is a very standard problem about with related rates, and it's the ladder problem. And so you've got a 25-foot ladder leaning against the wall, and the ladder falls down the wall. It's being pulled away from the bottom of the wall at a rate of 14 feet per second. At what rate is the top of the ladder moving down the wall when the top of the ladder is 7 feet from the ground? Okay, so the first thing we want to do is draw a picture of the situation, okay? So I'm going to zoom in real quick and draw a ladder, draw the picture of this. And so I'm going to draw the wall and the ground and the ladder, okay? And you're probably wondering to yourself, wow, Mr. Police, you're really good at drawing. Did you ever try to go to art school? And the answer is yes, but no one would take me. Okay, so, but what I want to do is go ahead and label this picture. The ladder is 25 feet. Okay, so I'm going to go in here and write that this is 25 feet. Okay, and I know that the ladder is being pulled this way. Okay, and as a result, the top of the ladder goes down like that. Okay, and so what I know is that this distance from the base of the wall to the bottom of the ladder changes. Okay, so I'm going to go ahead and give that a value and call that length x. Okay, and I know that this distance from the top of the ladder to the ground is also changing. It's moving down. So I'm going to give that a variable and call that y. Okay, and so what I know is that the wall or the ladder is being moved out at a constant rate. And since we're talking about a rate of change, I'm talking about how this distance x is changing with respect to time. So what I would do is I would actually write in here that dx dt, the rate at which this distance x changes, is equal to, and let me check and see what that was again. What is that? 14 feet per second. So I'm going to write that this is 14 feet per second. Okay, 14 feet per second. Okay, and we want to know at what rate is dy dt changing. Okay, so what's dy dt? Okay, when y is 7. Okay, so what I want to do is kind of write out what we know. And so we know that dx dt is equal to 14, okay? And we're trying to find, okay, we want to find dy dt when y is equal to 7 feet, okay? So as a result, let's think about something here. Is there an equation that we could write that relates three sides of a right triangle? Okay, and the answer is yes. Okay, we can write that equation. And so I'm going to write that here, write the equation. And what we know is that by my friend has a theorem, okay, and that friend is Pythagoras. And so I'm going to write that x squared plus y squared is equal to 25 squared, okay? And so what we want to do is take this derivative with respect to time, okay? So I'm going to do this. I'm going to take ddt of, and let me erase that so it looks nice. Ddt of x squared plus ddt of y squared, and that's equal to the derivative with respect to time of 25 squared, okay? So here's what we get. Okay, because the t and the x don't match, we're going to end up getting 2x times dx dt, okay? And then we're going to get 2y times dy dt, okay? And this is just using implicit differentiation, okay? And as a result, if I take the derivative with respect to time of a number, I'm just going to get 0, Okay, so we want to solve for dy dt. All right, so I'm going to move everything over and solve this equation for dy dt. And so I'm going to subtract 2x dx dt from both sides. Okay, and as a result, I'm going to get 2y dy dt is equal to negative 2x times dx dt. Okay, and then I'm going to divide everything by 2y, and divide everything by 2y. And so as a result, I'm going to get that dy dt is equal to, and the 2's are going to end up dividing out here, so I'm going to get negative x times dx dt divided by y, okay? And now what I want to do is actually plug in those values and see what we get. And so I know that y is 7 feet, okay? And I know that dx dt is 14, okay? But I don't know what x is, okay? But if I use my equation that I had with the Pythagorean theorem, I can figure out what x is. So I have to use that, okay? And so I'm going to come over here and I'm going to write what's x squared, or what's x when y is 7, and that's 25 squared. And so if you remember your Pythagorean triples, we know that x is going to equal 24. And so I get x squared plus 49 is equal to 625, okay? And if I subtract 49 from both sides, okay, I'm going to end up getting that x squared is equal to 576, okay? And if I take the square root of that, I'm going to get that x is equal to 24 feet, okay? All right, so I'm going to plug all those numbers in, and this is what we're going to get. Okay, we're going to get dy dt is equal to negative 24 times dx dt, which is 14, all divided by 7. Okay, and so I can simplify this, and the 14 over 7 divides out to 2, so I get negative 24 times 2, and that gives me negative 48. Okay, and this is in feet per second. Okay, the rate at which y changes with respect to time. Okay, and so that's how fast that ladder is moving when the ladder is 7 feet from the ground. Okay, so I hope you enjoyed this video. I'm going to go ahead and pause this and do the second example, but if you need to rewind and go back and watch that again, then let's go ahead and do that. Thanks. Bye.